In today's video, we are going to learn about operators in C language. C language has a rich set of built-in operators. So basically, what is an operator? An operator is a symbol that tells the compiler to perform certain mathematical or logical manipulations. Operators are used in program to manipulate data and variables. There are total 7 types of operators in C language. They are as follows: arithmetic operator, relational operator, logical operator, bitwise operator, assignment operator, conditional operator, and special operator. Now let's have a look on arithmetic operator. The first arithmetic operator is unary plus or addition. The next arithmetic operator is unary minus or subtraction. Then is the multiplication, which multiplies the two operands. The next is division, which divides the numerator by denominator. The next is modulus or modulo division, which gives the remainder after division. The next is increment operator, which increases the value of integer by 1. And the last is decrement operator, which decreases the value of integer by 1. So there are two types of increment and decrement operator. They are prefix and postfix. Let's take an example. Take an integer a. Prefix increment can be written as plus plus a, whereas postfix increment can be written as a plus plus. Plus plus a or a plus plus mean the same thing when they form statements independently, but they behave differently when they are used with assignment operator. In prefix increment, the value of operand is incremented by 1 and then it is assigned, whereas in postfix increment, first assignment is done and then increment is performed. Now let's have a look on this example. In this example, the value of integer a is 40 and value of integer b is also 40. So the addition will be 80, the subtraction will be 0, multiplication will be 1600, division will be 1 and modulus will be 0 as the remainder is 0. Now let's have a look on relational operator. The first relational operator is equals to. The next is not equals to. The third is greater than. The fourth is less than. Then is greater than or equal to. And the last is less than or equal to. Relational operators are used to compare two different entities, and the result of relational operator is always true or false, that is 1 or 0. Now let's have a look on this example. In this example, we have two integers m and n. The value of m is 40 and n is 20. So the condition is if m is equals to n, then print m and n are equal, else print m and n are not equal. So the compiler will check the condition and then print the answer. In this case, m and n are not equal, so the compiler will print m and n are not equal. Now let's have a look on logical operators. There are total 3 types of logical operators in C. The first is logical AND, the second is logical OR, and the third is logical NOT. For example, integer m is equals to 40 and n is equals to 20. If m is greater than n, logical AND m is not equal to 0, print logical AND operator both are true. In this case, the both values are true as m is greater than n, logical AND m is not equal to 0. This case is true, therefore the compiler will print logical AND operator both are true. Now let's have a look on bitwise operator. The first bitwise operator is bitwise AND, then bitwise OR, then bitwise exclusive OR, then is the left shift, right shift and bitwise complement. Let's have a look on this truth table. We have two operands, operand A and operand B. So if we write A bitwise and B, the values will be if both of the values are true, then only it will print 1, else it will be 0, that is false. For A bitwise or B, it is totally opposite. If both the values are false, that is 0, then it will print 0, else it will print 1. And for A exclusive OR, if both the values are true or false, then it will print 0, and if it is alternate, that is 0 1 and 1 0, it will print 1. Now let's have a look on these examples. The first example is 12 bitwise and 25. So now there are total 8 blocks. Starting from the extreme left hand side, it is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6 and 2 to the power 7. So 12 is the addition of 8 and 4. So there we have written 1 and 1, and 25 is the addition of 16, 8 and 1. So there we have written 1, 1 and 1. So 12 and 25 gives us 0, 0, 0, 0, 1, 0, 0. That is 8, as the 1 comes at the place of 8. So the next example is bitwise complement, that is negation. So the value will be minus n plus 1. So if we write bitwise complement 12, it will give us answer minus 13. Now let's have a look on left shift operator. We have taken an example of 60 left shift 1. That means 60 into 2 to the power 1, that is equals to 60 into 2, that is equals to 120. And for right shift, we have written 60 right shift 1, which gives us 60 divided by 2 to the power 1, that is equals to 60 divided by 2 equals to 30. Now let's have a look on assignment operators. The first assignment operator is equal to, that assigns the value from right side operand to left side operand, that is A is equals to B. So the value of B will be assigned to A. The next assignment operator is plus is equal to, that adds the right operand to the left side operand and assigns the result to left. That is A is equals to A plus B, which can be written as A plus equals to B. The next assignment operator is minus is equal to, which subtracts the right operand from the left operand and assigns the result to the left operand. That is equals to A is equals to A minus B, which is written as A minus is equals to B. The next assignment operator is multiplication is equal to, which multiplies the left operand with right operand and assigns the result to left operand. That is A is equals to A multiplied by B. That can be written as A multiplies is equal to B. The next assignment operator is division equals to, which divides the left operand with the right operand and assigns the result to left. That can be written as A is equals to A divided by B, which means A divided by is equals to B. And the last assignment operator is modulus is equals to, which calculates the modulus using two operands and assigns the result to left operand. That is A is equals to A modulus B, which is written as A modulus equals to B. Now let's have a look on this example. In this example, we have taken integer total, that is equals to 0, and integer I. For I is equals to 0, I is less than 10, I plus plus, total plus is equals to I. That means total is equals to total plus I. So the value of total will be 1, 2, 3 and so on. So the answer will be 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, that is equals to 45. So the compiler will print the answer is equals to 45. Now let's have a look on conditional operators. It is actually if condition that we use in C language, but using conditional operator we turn if condition statement into more simple line of code conveying the same thing. The syntax for The conditional operator is expression 1 question mark expression 2 colon expression 3. So the explanation for the syntax is the question mark in the syntax represents the if part. The first expression, that is expression 1, is used to check true or false condition. If that condition of expression 1 is true, then expression on the left side of the colon, that is expression 2, is executed. If that condition, that is condition 1 or expression 1, is false, then the expression on the left side of the semicolon, that is expression 3, is to be executed. For example, in this we have integer x that is equals to 1 and y is equals to x is equal to 1 question mark 2 comma semicolon 0. So it will print the value of x as 1 and print the value of y as 2. Now let's have a look on special operators. There are total 3 special operators. The first special operator is size of, which returns the size of the variable. For example, integer. The value or the size of integer is 2. The next special operator is the symbol of AND, which returns the address of the variable. And the last special operator is the asterisk, which is the pointer to a variable. Now let's have a look on operator precedence and associativity in C. So the first preference or the rank first is given to the function called array element reference, and its associativity is from left to right. The next is unary plus, unary minus, increment, decrement, logical negation, one's complement, indirection, address, size of an object, and typecast, and the associativity is right to left, and the rank is 2. The next operators are multiplication, division, and modulus, and the associativity is from left to right, and the rank is 3. The next operator is addition and subtraction, and the associativity is from left to right, and the rank is 4. The next operator are left shift and right shift, and the associativity is from left to right, and the rank is 5. The next operators are less than equal to, greater than equal to, and the associativity is from left to right, and the rank is 6. The next operators are equality and inequality. The associativity is from left to right, and the rank is 7. The next operators are bitwise and bitwise XOR, bitwise OR, and the associativity is from left to right, and the ranks are 8, 9, 10 respectively. The next operators are logical and logical OR, and the associativity is from left to right, and the ranks are 11 and 12 respectively. The next operators are conditional operator and assignment operator, and the associativity is from right to left, and the ranks are 13 and 14 respectively. And the last operator is the comma operator, and the associativity is from left to right, and the rank is 15. Now let's have a look on this example. In this example, we have 4 different variables, that is integer a, character b, float c, and double d. So the value of integer or the size of integer will be 2, the size of character data type is 1, the size of float will be 4, and the size of double will be 8. So the compiler will print the sizes of the respective data types. Thanks for watching this video. Hope you liked this video.